Hello friends, so today we're going to discuss the problem C and D from the latest AtCoder beginner contest 179. A lot of my members are requesting these questions, so I'm making a video on it. And the problem A and B are very simple, so you can solve them by your own, and if you still have any doubts, please mention down in the comment box. So let's start with the problem C. The problem C statement states that you are given some positive integer n and how many tuples of the format A and B, A, B, C of positive integers satisfy this following condition. So what does this question means here is you have to find out the possible tuples in which A into B plus C is equal to n. Now first thing which come to my mind is find out the constraints over these tuple values. Like the A, B, C cannot become very large. It cannot become 10 to the power of 100. Why? Because n is up to 10 to the power 6. You cannot make them equal to 10 to the power 100. So find out the constraint for every of the three tuple values or the integer values. So because n is up to 10 to the power 6, if A or B equal to, let's assume, 2 or very small number, then its value can be at most equal to 10 to the power 6. It will not become 10 to the power 6, but do an upper bound of 10 to the power 6 only. And A into B inclusive, both of these values cannot become 10 to the power 6, because if A is 10 to the power 6 and B is equal to 10 to the power 6, so both of the multiplication will become 10 to the power 12 and it will exceed n. So it means that either A can be 10 to the power 6 at max and then B equal to 1, or else B equal to 10 to the power 6 and A equal to 1. The multiplication of A into B is up to 10 to the power 6, not A and B differently equal to 10 to the power 6. Okay, so these are the upper bounds for A, B and C. Now you cannot iterate over individually A and B and then iterate over for A from 1 to 10 to the power 6 and then B in 10 to the power 6 and then find out the value of n. But the one thing what you can do is iterate over C, because if you iterate over C, C can be from 1 to 10 to the power 6. So let's assume that my n is equal to 100. Now if C is equal to 1, then take this C equal to 1 and put it on the right hand side. So it is 100, so 100 minus 1 equal to 99. So A into B is equal to 99. So my equation is find out the pair values in which A into B is equal to 99. So you can easily find out this value using you have to find out the factors of 99 actually. But because you have to find out a lot of factors, a lot of tuple, for C equal to 1, C equal to 2, C equal to 3, for all the values you have to find out the tuple, the values of the pairs. And there are a lot of pairs. If n is equal to 10 to the power 6, then for 1 to 10 to the power 6 there are a lot of pairs. So it's very difficult to iterate over C. But you can see that I can combine it, iterate over A and B. What does this mean? I can iterate over from A from 1 till 10 to the power 6, but I will iterate over B such that B is taking the value, because if A is equal to 1, then B is iterating from 1 to 10 to the power 6. But if A is equal to 1000, then B is only iterating over 1000 only. So as A increases, B value decreases, and the total summation of A into B is always 10 to the power 6. I hope you understand this point, because A into B is up to 10 to the power 6. Okay, so your total, the number of iterations you do will not increase 10 to the power 6. Okay, so that's the easy way to go over this question. So I'll take it on to the code part to make it even more clear. So what you can do here is total number of tuples you can form, take an input of n, and then iterate over from I, which is denoting A, from 1 till n, and B, which is denoted by J, is it also from 1 till n, but I will only iterate over such that I into J is less than n, which is A into B is less than n. And then for every positive value, because I into J, I'm iterating over the values from I into J, I will only do the values, I only add the values when I into J is less than n, because this will ensure that my C is positive. Why? Because actually I am only iterating over all the values which are less than n. A into B is less than n. If A into B is less than n, then there can happen that some C always occur, because let's assume that my n is 100 and my A into B is 2, 3, 4, 5, 6. So if my A into B is some value, then always some C will occur, and I will like update that C equal to like this A into B minus this N, and I can always get some different C. So that's what I'm doing. For all of these values I will increment my C, and that's the answer. So I can easily iterate over all the possible values and find out the answer. The second way you can do also here is pre-compute all the possible factors for every number from 1 till 10 to the power 6. Pre-compute the factors. Like there's an article on Geeks for Geeks to how to pre-compute the factors for all the numbers in one go. And then when you have computed the factors in a relatively small time, then you can, for every C value, you can find out the number of factors for A into B. Okay, because for every C value, if my C equal to 1, then I know what is the value of A into B equal to this. And if I've computed the number of factors of 99, then I can just easily add them. So I have to pre-compute that. There's an article I will link down in the comment box, so you can also check them out. So these are the two approaches to solve this problem. Now the fourth question is very good. Like according to me, it's one of the hardest, not hardest, but it is one of the an interesting DB problem. So whoever has created this problem, hats off to him or her. So the problem statement states that you are given L cells arranged in a row, and it is from 1 till L from left to right. So there is some row, and these are numbered from 1, 2, 3, 4, 5, okay, and so on. And then Tark lives in these cells and is currently on cell 1, so he's on cell 1, okay. And then what he'll do, he has to reach the ending cell, last cell, end cell. Now you are given an integer k that is less than or equal to 10. That is one important constraint in this. K is less than or equal to 10, okay. And k are non-intersecting segments. So you are given some non-intersecting segments such as this, this and this, such that the number of segments is always less than or equal to 10. And now let S be the union of these k segments. Now if you have to find out the union of these k segments, how you can find out the segments? Let the segment denotes that if a segment is from L to R, then you can have to find out all the I values between L to R. So it means that if the segment is from 2 to 5, then the segment which contain all the values is 2, 3, 4 and 5. It will consider all the values. If the segment is from 2 to 5, obviously it will contain the values 2, 3, 4 and 5. Okay. So now when you are on a cell I, you can pick any integer D from S. S means the union. So actually, as you can see from the example only, I will go down on the question also. But as you can see, there is a number line of size 5 and there are two segments from 1 to 1 and 3 to 4. Now if there is a segment from 1 to 1, how many numbers are there? 1, only 1. If there is a segment from 3 to 4, how many numbers are there? 3 and 4. So if you do a union of these two segments, you just take all the numbers from these segments and put them in some set. So this is the union, which is 1, 3 and 4. Now what you'll do, whenever you are on any ith cell, you can choose any integer from this union and jump this much steps from the starting point. What does this mean? If you are on the 5th position, you can jump to the 6th position, or 5 plus 3 8th position, or 5 plus 4 9th position. So you can jump from 5 till all of these D. So D is equal to the union of these ranges which is given to you. And now you have to find a number of ways to reach n. So I hope you have seen, or if you haven't seen my frog jump video on if there's a interesting DP series on the AtCoder only, AtCoder education DP series, on which the first and the second question are similarly same, in which you are given some frog and it can jump either 1 step or 2 step. It can go like this or it can go like this, and you have to reach the last step. Now how many numbers it can take? So let's assume here on the starting point, he can either jump one way or two way. So let's assume that the size of this n is equal to 2 only, or 3, and he want to reach this point, so he can either jump in this way. So there is only one way. But now if the length is equal to 5, 1, 2, 3, 4, 5, so in one jump he can reach in the first block or the second block. Now if you on this block, he can jump like this or he can jump like this. So if he can reach this way, he can go to this block like this, or he can go to this block like this, this, and then this. So how you can see, or how many ways are there to reach this block? How you can find out? You have to, for every starting point, you have to find out the number of ways to reach this state, to reach this block. How many number of ways I will take to reach this block? Then if I know that, okay, I have taken one step to reach this block, then I can, from this block, I can jump either one block or two block. So if the number of ways to reach this block is 5, then I can do one jump, then I can reach the other block in 5 ways only. So if number of ways to reach this block is 1, then I can reach this block in one way only and one way only. But now if I have reached this block in one way and I want to reach in this block, so like from this block I can go to this block in one way only, but I can go also in this block, but there is also one there, so I will add one to it, which means that, okay, I can reach this block via this way or this way. So there are two ways. As you can see, there is one this way and there is that directly one way. So how I can find it out? I will find out the number of ways to reach this block, and then I will subsequently add how many jumps I can do from this block, and I will update all of these values with the particular number of jumps I can come at the particular block, and I will update all the further values from this. So this is the similar problem in which you are on the ith block and you have to jump. Like in the simpler value, you can jump one value, two values, it is simpler to update. But now in this question there are a lot of values you can jump, like because the updation values are very large, the ranges can be very large, up to n. So there are up to 10 to the power 5 like numbers. So it can happen that from 1 I can jump to 2, 3, 4, 5, 6. So for every value I have to update all the values. So it will be like O of n square value, so you cannot do that. But if you want to update some range and you have to update it in continuous manner, the first thing which come to my mind, which is very easy to like apply, is range updation using the array, in which like you have some particular blocks and you want to update all of these values to 1, then just add 1 to this point and subtract -1 to this point, and then do a range left to right move, like do a range or like iteration from left to right, and then whenever you find out 1, just put down 1 to it, and then again increment 1 to it, 1 to it, and then whenever you see -1, just stop at that point. So like you have incremented all the range to like 1, which I have marked. So that's the simplest way to update some range. So that's what we're gonna do in this question only. So we will make two vectors actually. One vector will store the updation we'll do, and the other vector will store the number of ways. So this is prefix sum. I have made two vectors, prefix sum, p sum, and dp. dp will actually stores. So what we'll do actually, I'll tell you. P sum 1 is equal to 1, which means that for reaching the first value there's only one way. Now for every value I know that I can jump or do a range query or range updation, sorry, for every value I know that there are some segments. So for the first segment, let's assume that there is one segment like this, one segment like this, one segment like this. So for every value I can do a jump. So let's assume that this is 1, 2, 3, 4, 5, 6, 7, 8, 9, which means that from the particular value I can either jump 3 ways, 4 ways, 6 ways, 7 ways, or 9 ways. Like I can even jump a jump of 3 units, 4 unit, 6 unit, 7 unit, and or 9 unit. So what I will do here is for every value I will update 3 jumps till 4 jumps. So I can either do a jump of 3 till 4. So how we can update? I can update it in the dp way, like dp array, but I will update it from like -1 because I can do a jump from, I can do a jump of size 3 or 4. So for the particular dp value I can do a jump of, so because I can do a jump, I have to update all the values from 3 to 4. So I will update from 3 till 5 because I have to add 1 at the 3 position and -1 at the 5 position, what I have told you in the updation range query. So I will add, like if I'm on this point I will do a 3 jump at this point. So I will add +1 to this, and like 2 jump and -1 to this. So I actually do this in this TP array, not in this. So that's what we're gonna do. And then after doing this, it's a little confusing, but the core idea is I have to store the ranges, and then according to the ranges, see what I've told you in the frog question, we have to find out the total number of ways to reach the particular state, and then from the particular state I have to find out how many jumps I can do, and for all those jumps I have to update the total number of ways to reach this particular state. Then I will update this state to all of the jumps I can do. So this DP will store what are the jumps value I can do. Like I can do a jump for 3 to 4, or like 6 to 7, 8 to 9. And the prefix like psum will store, okay, what is the current number of ways to reach this particular block. So if I want to update psum, then psum will store the particular number of jumps to reach this state. Then I will take this psum value and update in all the ranges, because see, in all the ranges I have to update the number of ways to reach that, like the number of ways to reach all of the other values. How many number of ways is the number of ways to reach this particular state, plus how many jumps I can do. And the number of jumps I can do is I have to take all of these ranges and then the particular sum plus this range starting value and ending value. So because in some range query I can do +1 and then -1. +1 means that I have to take some like value, because I have to do a updation of only 1 in this whole range. But now I have to do an updation of like psum, then I will do a plus psum at the starting and minus psum at ending +1. So that's how I'm gonna store the psum value and the DP value. It's a little confusing, but stay with me. So then for every psum value I will update this DP value, and then using this DP value I will again update my psum value, which is equal to the number of ways to reach this point. So I'll take down to the code part to even make it more clear. So this is the code, in which what we are going to do here is we will make an A vector and a segment vector. So segment vector will store the left and the right value. Okay, and then what we're gonna do here is take the input of L, like N and K. K is the number of segments, so store the segment in first and right, like this is the segment I, first and second. Then there's a two variables like DP, so this is like this no use. There's like two vectors DP and psum, which I've told you. Initialize my psum equal to 1 because there is only one way to reach the first block. Then for all the further blocks, what we're gonna do, we have to update our psum. So because psum is actually equal to the prefix sum, so if you want to update my prefix sum, how you can update the prefix sum? Taking the previous value and the current value, add the current value with the previous value. So we have to update my psum, which is the current ith value, is equal to the add the like previous value with this current value. Because everything is mod, I have used this add function and I have updated my m equal to the given mod value. Okay, now for the rest of the values I have updated my psum value, and I have to also update my psum value in the dp value, because see, dp value will actually update the further segments, because I have to take this particular psum value, and what I have told you, I have to update my psum -1 and plus psum and minus psum. So I have to update this value in my dp, because dp is the range value. Dp stores what is the range I have to update, so from the starting and the ending. This psum is stored the current value till now, but dp stores if for every psum I have to update all the ranges. Now so updating all the ranges I am storing in the dp table. So now for every I value I will iterate over all the ranges, and what will I do? I will check that, okay, if I'm on the ith point, I have to jump segment, like there's a segment of 3 to 4, so like there's a segment of 3 to 4, which means I can do a jump from 3 to 4. So I can check that from the ith point, can I do a segment, can I jump to segment j plus first, which means that the 3, so it is less than n. Then what will I do? I will update this segment jump in the DP table which I've told you. So how you can update this? DP table of this segment value is the current DP value plus psum. So psum actually stores the current value till now. That's what I've told you. I have to add this with the psum value. So that's what I'm adding, the current DP value. So I have to update the plus value and the negative value. So the left part is the original part, which is like segment of j plus, like segment of j dot first, and the last value is segment of j second plus 1, because I have to update plus 1 to the current value. And then I have to check that okay, whether this is also inbound. If this is inbound, then I have to take the DP value at that state, and then I have to do a minus sign. I have to do a negative of that current value and do a minus of that or the psum. So like these are two functions which I've made to make my modulus function very simple. So these are the add function, this is the minus function, which is just taking this modular function and easily adding and doing a minus subtraction value. And in the end, the answer is just stored in psum, because psum is storing the total number of ways to read the nth block, and that's it. So it's a little bit confusing, but if you draw it on some paper, or like solve this function, see this code like 1, 2, 3 times, so you will keep on absorbing. I have to also see this like code from somewhere else, because this is a lot bit confusing for me to understand. But like after seeing this code for like 2, 3 times, I am like understanding what the core concept of this code is. So I hope you understand this concept also. If you still have please doubts, please mention down. Thank you for watching this video. I'll see you in the next one. Keep coding. Bye.